Hello, my name is Arlen Nipper, and I'm the President and CTO of Cirrus Link Solutions. Cirrus Link was established to provide best-in-class IoT and IIoT software, empowering our customers and ecosystem partners to easily design, build, and deploy their superior IIoT solutions. Cirrus Link is also proud to be a strategic partner with Inductive Automation, providing a complete portfolio of MQTT and cloud service modules for IIoT applications using the Ignition Industrial Application Platform. Cirrus Link have developed 3 MQTT modules for use with the Ignition platform. The first module we developed was called MQTT Engine, and basically MQTT Engine is an MQTT client that knows about the spark plug specification and can connect into MQTT Infrastructure and subscribe to messages from devices from our partners within the ecosystem, and then take the device information and tag information and automatically create tags within Ignition. The next module we developed was called MQTT Distributor, and basically Distributor is just an MQTT server that runs on the Ignition platform so our customers can get up and running very quickly. And then the last module we developed is called MQTT Transmission, and with this module you can take any tag that exists within your Ignition gateway, whether it's OPCUA tag, memory tag, calculation tag, and be able to publish it back out to an MQTT infrastructure using the spark plug format. Although MQTT has become one of the dominant message transport technologies for many IoT solution providers, early on Cirrus Link recognized that for industrial IoT, no standards existed on how best to use MQTT in an industrial, mission-critical, real-time environment. So, in May of 2016, the development team at Cirrus Link combined our over 80 man-years of experience using MQTT to create a specification called Sparkplug. Sparkplug provides the industrial-centric definition of a topic namespace, a process variable payload definition, and a real-time state awareness that is a core feature of MQTT. Then, using the Sparkplug specification as our guide, we developed reference implementation code in C, Java, JavaScript, and Python. Once this was complete, we placed the specification and reference code on our public GitHub site for anyone to download it and implement it. In the last 18 months, this ecosystem of both OEM equipment manufacturers as well as software solution providers have downloaded and implemented the MQTT Sparkplug specification. And this is what we're going to demonstrate today.
Now let's take a look at the infrastructure that we're going to be putting together in this demo. Now remember, with MQTT, we're talking about decoupling devices from applications. So we're going to have a population of edge of network devices and native devices, all connecting in over various network infrastructures into an MQTT infrastructure. So note at this point that we don't have to have any ports open out in the field. These are all remote originated MQTT connections using TLS 1.2 security for encryption and authentication. And so now we have all of these devices and they're already connected into this MQTT infrastructure. Now what we're going to do is then show, by plugging in Ignition and MQTT Engine, we'll be able to discover this infrastructure and then see what happens. So what we're going to do is actually go into the web console of the Ignition gateway that we have running and just look at the configuration. So first we'll just look at the modules, and you'll note that this is a standard installation of Ignition gateway, but then down here you'll see we have the Cirrus Link solution modules installed. And for this demo, let's look at the fact that we have MQTT Distributor and, most importantly, MQTT Engine installed. Now when we install Engine, we get a tab to set it up. And so the first thing to note here is, let's take a look at their MQTT servers. In our demo topology, we have 3 MQTT servers out in the world. Now, we really don't care where these MQTT servers are. They could be on-premise, They could be in the cloud. The fact is now Ignition with MQTT Engine knows about 3 MQTT servers that are in the infrastructure. Now also note that for right now, we've got MQTT Engine disabled. So now if we were to open the dashboard here, the designer, I'm not going to launch it, I've already got it open. And we'll take a look at what the dashboard or what the designer looks like. Now you'll note here that when we installed MQTT Engine, we got a new tag provider. But right now, it's not very interesting. We don't have any edge nodes, we don't have any devices, but we do know that the tag structure we could use to create a dashboard in Ignition. Now this dashboard will tell us as devices start being discovered automatically by Ignition, there will be a green square appear here in this gray area. We'll get our edge nodes and our device count will increment. So let's just see how long it would take to discover around 1,400 devices with about 58,000 tags. So let's go into our MQTT Engine configuration, enable it, and save that configuration. And now let's just watch the dashboards. And now here we are, about 12, 13 seconds later. We now know about 1,424 devices with 58,000 tags. Just go to our status settings with 58,000 tags all discovered in about 13 seconds. So you can imagine just the man hours that we saved right there in the fact that all of our devices, all the metrics and all the tags are already in our system. So now if we go over here and refresh Engine, we see that we've got Advantech devices, the new switch that they've got that's MQTT enabled, the Uno Edge, the Alexis ReadyGate connected to 2 PLCs here in our office, the Easy Group Automation PLC. We've got an Edge computer running Ignition Edge talking to a Click PLC with all of its tags automatically discovered, 2 Moxa devices, one running Things Pro natively, the other one running Ignition Edge as well. We've got a Hilscher Net IoT talking to an Allen Bradley PLC, and we've got 2 Opto22 Groove boxes, one of them connected to a Snap Pack. Again, the thing to note here is that we discovered all their tags and all their metrics, and we'll get into more of the source of truth of the tags. Now, the other thing to look at here is that not only do we know about the devices and the tags that are out in the field, we also have a very good view of the infrastructure that we're talking over. So part of this is in the MQTT Engine info and our clients so that we can keep good metrics on our MQTT infrastructure. So you'll see here we can tell you when we connected to a server, when it went down, how many messages per second it's getting, and we can actually build a dashboard in Ignition to give us these metrics. And so we can see here that we've got about 1,600 tags per second flowing in through these 3 MQTT servers. And we're measuring the latency of when the tag was published, when it arrived at the Ignition, and how quickly we're processing messages that are in our queues. And all of these measurements are in milliseconds. So not only that, we can go in here and for each device, you'll notice in this matrix that we put up, we can actually double click on that and actually pull up the metrics for a device. Tell us its current state, its birth count, when it came online, and when it went offline. Now, the other thing we can take a look at is that since we're now using Ignition, we can take a look at what kind of efficiencies are we getting here. So what I'm showing here is a Moxa 8100 connected over cellular, and it's set up to poll 5 IO-Logix Modbus TCP IO modules. And so we can see here that we can actually turn on a relay. What we're going to do is publish a command to that relay. It's going to turn on out in the field. That caused the relay outputs are tied to the digital inputs, which caused the change there, and that was immediately published back. Now, for the purpose of this demo, we've got an Ethernet switch in here that we can actually power on and off through relay number 4. So we're going to turn off that Ethernet, the power to that switch. And what you're going to see is that Since we got failure in the field for our Modbus TCP polling, immediately using Sparkplug, we were able to publish a death message for these two devices. Ignition staled the device metrics, so now we know they're offline, and all the tags appropriately. Now, the other thing that's interesting to note here is I'm going to reset the metrics, and even though we're polling at 100 milliseconds out in the field, you can see that we have no data that's actually being transmitted. Because remember, we have state in MQTT. We know this relay output's on. We know this digital input is off. But as soon as we publish something, it changes. That's immediately picked up. And so what you're looking at here is almost 100% bandwidth reduction, but yet 100 milliseconds response time of our overall system. And we can also do things like we can, with MQTT Sparkplug, we can say that, oh, well, we would like you, Moxa 8100, to move to the next available MQTT server, which it just did. And we'll turn our Ethernet switch back on. Now, the next thing to look at is that, let's go back to our infrastructure. You'll notice here that, we've got 1,400 devices, we've got 58,000 tags, so all of this infrastructure is pretty crucial. So we can see here what would happen if our MQTT server number 1 actually went offline. So we'll log into that server, and we'll run a script command that will actually stop that MQTT server. Now, from a SCADA standpoint, what we're interested in is how quickly will Ignition know that around 400 devices, 200 edge nodes went offline, but then appropriately set their state to stale, set all the tags to stale, and all of that be recognized, and then how quickly will our network infrastructure recover. So let's watch this right now. We'll execute this command. That broker will become unavailable. We now have 400 devices offline. But, well, wait a minute. Now we only have 300 devices offline. So, again, with very little effort, we're able to add availability and redundancy simply by adding more MQTT servers to our infrastructure. And you can see here in about 13 seconds later, we've basically recovered the entire infrastructure, and we're back up and running. So we'll turn this server back on, and you'll notice that in MQTT Engine, that server immediately becomes available. Now, what we're going to do now is, the last thing we'll look at is this notion of, now that I'm using MQTT to publish from the edge, and we've got intelligence at the edge, now we can look at the edge devices, or the devices in the field, being the source of truth for our tags. So what I'm going to do is open a embedded Linux device running Ignition Edge, and note its folder structure. Now we're going to open that same designer on that Ignition Edge, and that's on the right. So the designer on the right is an Ignition Edge running on a Raspberry Pi out in the field, polling a Modbus PLC over TCP. And we can look here that in that folder structure, we were able to go to the OPCUA browser, grab tags, and pull those tags into the folder structure that we wanted. But notice that instead of these tags being rather cryptic, 1.v1 or y.y8, they're actually indicative tag names. So let's take a look again at that folder structure. This is our Ignition gateway on the left, and notice that we have pump 1 control. Well, if we send a command to turn that on, we see that it turned on out here at the PLC that this edge of network device is talking to. Actually, we've got an evaluation script running here, our expression script, that's looking at that state and then creating a string back into our tag structure. And so that when that pump goes off, we create a string called stop, and you can see here that that's immediately updated here. Now, first thing is that, notice this case pressure. Well, we can look in the tag description, we can see that its tag path to the OPCUA polling engine was 1.v10, but now we're calling it case pressure. But more importantly, instead of this being a rather nebulous register value, say 40,012, and it's a value between 0 and 4095, now we're saying, well, actually, that is in engineering units. It's 0 to 250, and that is in kilopascals. So if we take a look at our tag that we discovered with all 58,000 of them in 13 seconds, we can see that we not only do we know that that's case pressure, we know the engineering units and we know its engineering range. Now, the other aspect of this is that the edge of network device is always the tag authority. So let's just say, for sake of argument, that at this particular site, this isn't tank 201, this is actually tank 197. Now, note over here in my ignition gateway, that's still tank 201. But as soon as I change the name of that tag, notice that that tag is now stale and its value is null. So everybody that's subscribed to this infrastructure now knows that that tag name and that value no longer exists out on our edge devices. Then what we do is once we got our tags the way that we want them, we come in and click refresh. Now that's going to republish all of the tags this edge device knows about. And now if we go and look in our ignition gateway, we now have a new tank 197. Its value is 129. And we can also look here to make sure that it got its engineering units. Oh, well, notice here that, that's tank volume. The engineering units for tank 197 are in meters. Now, let's just go ahead and look at that tank volume while we pulled it up. That didn't have any engineering units, so let's give that engineering units of cubic meters, whatever the engineering units for that is. And now let's refresh our tag browser again. And notice over here that when this device comes back online, we'll look at our volume, tank volume, and we'll pull the tank volume, and we'll now note the new engineering units. So really what we're trying to show here is that with MQTT infrastructure, we can automatically learn all of our infrastructure very, very quickly. We can create those tags, we can manage those tags, and that once the system is deployed, those edge of network devices are always the source of truth for our tag information.
Now let's summarize what we just saw in this demonstration. The first aspect of an MQTT-based infrastructure we saw is that we were able to show devices connected to infrastructure instead of devices being connected to applications with protocols. We saw that we already had devices connected to an infrastructure, but that Ignition platform didn't know anything about these devices. Then, when we enabled the MQTT engine and basically plugged Ignition into the infrastructure, we saw that Ignition was able to auto-discover over 1,400 devices, 58,000 tags, in around 14 seconds, with all of their properties and metadata. We'll reiterate the second summary point here is that all of this was working with Ignition. This is a very key aspect because with Ignition as the on-ramp to industrial Internet of Things, we still have to be able to demonstrate that operationally we can provide a better, faster, more scalable, more available, and more reliable SCADA solution. Because MQTT is remote originated TCP/IP connection and we can leverage TLS, we demonstrated a far more secure operational infrastructure, one that doesn't require any TCP/IP ports open in the field, reducing our cybersecurity risk by at least 50%. Using the MQTT Sparkplug specification with binary payloads and event-based pub/sub, we were able to see a faster, more efficient communications with an 80 to 90% bandwidth reduction over what we would have been using with poll response protocols. Using multiple standard MQTT servers, we were able to demonstrate a highly redundant and scalable infrastructure design that is very simple to configure and maintain. Using MQTT Sparkplug, we saw how powerful the auto-discovery of devices and tags is, and the benefit of the devices in the field becoming a single source of truth for tags. Just imagine the time spent manually editing and configuring these 58,000 tags. In many projects, this would represent many man-months, if not man-years, of error-prone editing, not to mention the long-term maintenance of tags over the life of the system. Finally, we showed many of the benefits of connecting devices to infrastructure instead of devices to applications. Although the Ignition platform in this demonstration was a very important MQTT client from an operational standpoint, it does not have to be the only client. We are going to see more and more applications and solutions leveraging MQTT technology in this migration to IIoT-centric solutions. In this demonstration, we saw real technology available today providing a superior operational solution ready to launch into your IIoT solutions across your enterprise and beyond. So everything I just demonstrated to you is available for download from Inductive Automation today. So go to inductiveautomation.com, download Ignition, download the MQTT modules from Cirrus Link, and you can get started with this technology today. Thank you.